Hello 20-2 students. So today we're looking at lesson 7.2. Now if you notice, our last lesson was, I think it was 6.3. So these lessons are actually out of order, and I've designed them to be that way so that they kind of build on each other. So don't worry about it if you're wondering, like, did you miss lessons or whatever. It should go 6.3, 7.2, and then in the order that they're listed on the website, basically. So we looked a little bit at what a quadratic function was last time and kind of the basics of putting those into our calculator. But another thing you need to be able to do is work with solving them just through mathematical operations, so not using your calculator necessarily. So that's what we're going to be looking at today. So we learned that last lesson, that it was the basic function, or the standard way of writing a quadratic function is either y equals ax squared plus bx plus c, or f of x equals ax squared plus bx plus c. So a related equation that we can use for this is 0 is equal to ax squared plus bx plus c. And when we set the equation up like this, all it means is that if we're looking at the graph of this quadratic function, the y value, we're looking at it when the y value is equal to 0. And so basically that would be, if we look at this graph over here, the points on this parabola where the y values would be 0 would be right here and right there. And so those are the x-intercepts, is kind of what we've commonly called them. But when we start to work with quadratics, we have a couple of other names for them. I'm not sure why we need to have so many names. They can be called zeros because they are the values of x for which the equation is equal to 0. Or they can also be called the roots. They can be called, sometimes if you just have the single parabola, they're called the solution. Or they can be called the x-intercepts. So it's really important that you're aware that if you're asked for the zeros, it's the same thing as the roots or the x-intercepts. So all of these words are interchangeable, and you need to recognize them as such. So if we look at this example here, if you were asked for the zeros of this graph, we would say, it looks like maybe there's a spot here at right about -1, and then the other one here is just a little bit before 3, so maybe like 2.8 or something like that. So we would say the zeros of this graph, or the roots of this graph, are -1 and 2.8, so just the x values of the x-intercept. So we want to learn a little bit about how to figure out what the zeros are by using factoring. So if we start out by looking at, if we had a multiplied by b equals 0, which values of a and b would make this true? So essentially when we're multiplying, we know that if we had, like, say 3 times by 0, we would have 0. If we have 0 times by 5, we would have 0. So essentially any number multiplied by 0 is always going to give us 0. And so if we wanted a times b to equal 0, either a could be equal to 0 or b could be equal to 0, or they could both be equal to 0. But those are the values that would make this expression be equal to 0. What if we had the expression a times by a minus 1 is equal to 0? How could we figure out which values of a would make this true? Well, again, we see that a would be being multiplied by whatever value is inside this bracket. So if we have anything being multiplied ever, we know that if that value is equal to 0, then the whole expression will be equal to 0. What if inside of the brackets we had, and actually I probably should have used 2 different values for this. Let's maybe say that this one is a, and let's call this one d, because that's easy to draw on there. So what values of d could make this true? Well, because it would have to be something different than a, right? So if we had d minus 1 is equal to 0 and we want to solve for that, again we know that if a multiplied by this whole bracket was, if what's inside this bracket was 0, a multiplied by that would equal 0. So we want to say if d minus 1 equals 0, that would make this whole expression 0. But that doesn't tell us what the value of d is. So in order to solve for d, we need to isolate it. And we would do that by adding 1 to both sides. So when we do that, we find that we have d is equal to 0 plus 1, which is 1. So now we would say which value of a or d makes this true. We could say if a was equal to 0 and d was equal to 1, then the expression would be equal to 0. Either one, right? So if either one of those is true, then the expression is equal to 0. For the next one, we have x plus 3 times by x minus 2 equals 0. When is this true? So now we have a little bit more information here. So x plus 3, if we wanted, again, we have two brackets being multiplied. So if this whole bracket was equal to 0, then that would be true. If this whole bracket was equal to 0, then this statement would be true. So essentially we want to say if x plus 3 was equal to 0, then it would be true. So we need to isolate what value of x would make that. We need to minus 3 off of both. And so we end up with x plus 3 minus 3 cancels out. 0 minus 3 is negative 3. So if x was negative 3 plus 3, we would have a 0 here. And then same thing for this one. So x minus 2 equals 0. So again, if we isolate x, that means plus 2 plus 2. And so it would be x is equal to 2. So if x is either minus 3 or positive 2, then this whole expression would be equal to 0. Okay, so that's our solution there. So the conclusion that we can draw from this is that if we have 0 is equal to ax squared plus bx plus c, if we have this in our factored form, it's going to allow us to find the zeros, because as we learned with factoring, right, we can have this format, and when we factor it, we break it down into two brackets like this. Once we have it in those two brackets, as you can see, it's pretty easy to set each bracket equal to 0 and solve for that. So essentially that's what we're doing when we're factoring these brackets, is we're just trying to find the values of x that will give us a 0 on the other side for the y. Now really quickly before we move on, I just want to point out it's going to be really handy for you guys if you become familiar with what the patterns are here. So basically if you have x plus 3, the value that will make it into 0 is the opposite of the value here, right? So we see that when we had plus 3, negative 3 will make it 0. When we had negative 2, positive 2 will make it 0. So if you become more familiar with this, at least if you're in a time crunch on a test, you won't have to do this full worked out solution if you don't want to. You can just kind of know that it's going to be the opposite value to solve for that. So let's try some examples where we're going to factor to find the solutions, which is another way of saying the zeros or the x-intercepts. So in this one, we have 0 equals x squared minus 81. First thing you want to recognize here, we have two terms. Whenever we only have two terms or a binomial, we always want to determine whether the two terms are a perfect square. So if we look at x squared, we can square root that to x. And if we look at 81, we can square root that to 9. So remember, that just means we're going to have a bracket that's going to be x plus 9. Now remember, in order to eliminate the middle term and to make our 81 negative, we would need to multiply positive 9 by negative 9. So our second bracket is going to be x minus 9. Right, so that's how we factor those perfect square binomials. We call them a difference of squares. And so now that we have this, we can think about which values of x will lead to this whole expression being equal to 0, right? Because we had 0 equals x squared minus 81. So again, that means each bracket would have to be the opposite. So because we have a plus 9 and a negative 9, in this bracket we would need negative 9, and in this one we would need positive 9. So we can say that x would have to be equal to plus or minus 9, and that would be our solution. So essentially what that means is, let's see, if we were to draw this graph, I'll just do a light sketch here. First of all, before you ever sketch a graph, even though we're not going to be super precise, make sure you pay attention to the value in front of x squared. We have nothing there, not a negative sign, so that means it's positive, which means it opens upwards. And the a value is 1, so whatever, we're not drawing a precise graph, so that doesn't matter too much. But basically, we're going to have a graph that opens upwards, and its solutions, or its x-intercepts, are going to be at -9 and +9. So let's pretend those are evenly spaced. -9, 0, and +9, 0. So we can start to see how when we know these kind of basic relationships, we can kind of estimate what our graph would look like. So we have a little bit of an idea there. Okay, in this next one, factoring again to solve. So we have a value in front of our a, and we don't want to have that. So let's use the swing method. So remember, that means we're going to swing the 3 over to the end. So we're going to be left with a squared minus 13a. And then that 3 swung over to multiply by the 10. So 10 times 3 is -30. And then we want to see what are two numbers that multiply to 30 and add to 10. Add to 13. So multiply to 30, add to -13. So we could do 2 times by 15. Oops, 15. And then for 13, that would be, if we want it to be -13, we would need +15 and -2. No, wait, the other way around. -15 and +2. Oh, shoot, and now I don't know where I put my whiteout. There we go. Sorry about that, guys. Okay, so it'd be the other way around. It's going to be -15 plus 2 would give us -13. Okay, so we actually have our value right away, which doesn't always happen that nicely. So that means our values are going to be a minus 15 and a plus 2. Okay, so then because we swung that 3 over, remember we need to divide it out. So divide that out. And we're going to be left with 15 divides into 3 evenly. So we're going to have a minus 15 divided by 3 is 5. And then in our next one, 2/3 is a fraction. It's not going to divide into an even whole number, so we're going to swing that 3 up in front of the a, and then plus 2. Okay, so now we have our two brackets. So if we want to solve for our values of a, that would set this whole thing equal to 0. The first one is easy, a minus 5, so we know that that would be a equals plus 5. The second one is a little bit trickier because we see that we have other numbers in here, right? But the same method works for solving it as being equal to 0. So you would say 3a plus 2, we want that to be equal to 0 so that when these two multiply together, right? So we just have an extra step. So first we want to subtract off the 2 to work towards isolating our a. So we're going to have 3a equals -2. And then we want to get rid of that 3, so we need to divide it out. So that's going to leave us with a being equal to -2/3. And as you guys become more comfortable with doing this factoring and solving for the zeros, you'll find that this becomes intuitive as well, because just the way this one's pretty easy to say, okay, well, 5 minus 5 is obviously 0. Every time that you do one where it's set up like this, where you have a value in front of the variable and then a number there, it's always going to be the opposite sign of what's in the middle, just like it was for the other one. So it's going to be negative, and then it's going to be a fraction of the last number divided by the value that's being multiplied by your variable. So that means our roots are at 5 and -2/3. So I'm not going to sketch that one out because I used up all my space there. But it'd be the same thing, right? Like it'd be, say if we looked on this same graph, -2/3 would be like kind of right here close to the 1. And then 5 would be, I don't know, maybe kind of like right around there. And we had a positive value here. So that means our graph would also open up. So we would have something kind of like that, okay? Even though I didn't quite hit my mark there. All right, let's try one more. Important thing to be aware of here is if you're trying to solve, if you're looking for like the roots or the solutions, it means that it always has to be set equal to 0. So before you can work with this, you need to get rid of the number that's on this side, move it away so that you're left with 0. So if -25 and we want to move it over, we're going to do +25, and same thing on the other side. And so then we're going to have 5m squared plus 30m plus 25 is equal to, and then negative 25 plus 25 will give you the 0. So now that we have this, we see that we have a trinomial, but just be careful because as you can probably see, this has a common factor we can pull out before we try to factor it into brackets. So all of these have 5 as a factor, so let's divide that out before we get started. Remember, always do your GCF first. So 5 divided by 5 is 1, so we're just left with 1m squared. 30 divided by 5, we have positive. 30 divided by 5 is 6m. And then positive 25 divided by 5 is 5, and that's equal to 0. And then just remember, because you divided that 5 out, you need to leave it in front of the brackets there. Okay. So now we can factor this. So we need two numbers that multiply to make 5 and add to make 6. So that'd be 5 times 1, I'm guessing. 5 times 1, 5 plus 1. Yep, that works. So my brackets are going to be, again, keep the 5 out front, and it's going to be m plus 5, m plus 1. So now another good thing to be aware of is that for this one, you can leave the 5 factored out. Your zeros are still going to be the same because you still want each bracket to add up to 0 to make the whole thing equal 0. Should set that up in there. So again, our answers are going to be fairly straightforward. It's going to be negative 5. And oops, didn't do that very well. M equals negative 5 and m equals negative 1. Okay, so those are my two possible solutions. So that means if I were to draw my graph, I would have, negative 5, negative 1. I had a positive a value there, so it's going to open upwards. So in a general kind of sketch, my graph is going to look something like that. Okay. Let's do one more example here. Actually, I think there's more than that, but what quadratic equation in the form 0 equals ax squared plus bx plus c would have the zeros 1/2 and x equals negative 3? So in this kind of a question, we're actually kind of working in reverse. So really, it's not that complicated though, because if you think about what we would do here, right? We're basically saying if we had m plus 5 and set it equal to 0, that's how we end up with this answer. So we're going to do the same thing, but in reverse here. So we'd say, okay, if x equals 1/2, but we want to move this around so that everything is on the same side as x, and we have 0 on one side. So I'm actually going to set this up. I don't know why, but when I'm doing algebra, I like to have my fractions like that. Okay, so if I have x is equal to 1 over 2, and I want to get this stuff over to where the x is, so that I'll have something kind of set up like this, the first thing I would need to do is I have 1 divided by 2 on this side. So to undo that, I need to multiply both sides by 2. So that's going to give me 2x is equal to 1. Okay, now if I want to get rid of the 1, I basically just have a positive 1 there. There's no operation being done to it. So to move it away, I just need to subtract 1, so that will get down to 0. And that means I have to subtract 1 off the other side. So that's going to leave me with, I'm actually going to write it over here, 2x minus 1 is equal to 0. Okay, so that's my first bracket. Now same thing here, x is negative 3. You can probably guess that our bracket is just going to be x plus 3, so a little bit easier than this one, but we can work it out really quickly. So we have x is equal to negative 3, and in order to move everything away and have a 0 on this side, we need to add 3 to both sides. So that's going to leave me with, I'm going to do it this direction again, x plus 3, I'm going to put it in brackets, is equal to 0. So now I have my two brackets, but they want us to give the equation in this form. So always being really careful about reading the the question properly and giving the full answer that they're asking for. So basically that means if we have these two brackets, 2x minus 1, x plus 3, those are our parts of the equation that are going to add up to 0 or multiply out to 0, I guess is the better way to say that. But if we want it in this form, we always need to FOIL out these brackets. So if we do the first, we get 2x times x, which is 2x squared. If we do the outside, 2x times 3 is plus 6x. If we do the inside, it's negative 1 times x is negative x. And if we do the last terms, we end up with negative 1 times positive 3 is negative 3, being equal to 0. Now just simplify by combining like terms. So we have 2x squared plus 6 minus 1, so that's plus 5x, minus 3 is equal to 0. And that's our final version of that equation. Okay. All right, so like I said, I thought maybe we were getting close to the end, but we actually have 2 more examples here that should be fairly quick. They're just going to be a couple of word problems. So we're again going to look at building our own formulas. This is a really important skill to have. It's usually all the word problems are like this. So in this one it says we have a parking lot in the shape of a rectangle. Usually if I have questions like this, I like to kind of start out by drawing it if it's something that I can kind of visualize. So we have a parking lot, it's a rectangle, and it's saying its width is 9 meters less than its length. So there's kind of 2 ways you could do this. So let's say I would call this the width and I would call this the length. So either you can say the length, we want to come up with a variable to represent one of these, right? Its width is 9 meters less than its length. So personally what I would do here is I would say the length is x and the width is 9 meters less than x. So that means it's going to be, the width is going to be x minus 9. But you could have also done the width was x and the length was x plus 9. Okay, either one of those would work. Then we're told the total area is 252. And algebraically, we need to find the dimensions. So basically, that means we need to figure out what is x. And then once we know what x is, we can solve for the width because we know it'll be 9 meters less than that. So if we need to find the dimensions, the only other value we're given here is 252 for area. So what do we know about the relationship between length and width and area? Well, we know that area of a triangle is length times by width. So basically, we know that if the area is 252 meters squared, so our units are going to be in meters, 252 is equal to the length, which we're representing with variable x, times by the width, which we're representing with x minus 9. So now we have the beginnings of an equation, right? What I would do next is I would expand out this statement here on this side and try and simplify it. So 252 is equal to x times x is x squared, and x times negative 9 is minus 9x. So now I have this set up. Now, if I want to solve it, remember my equation always has to be equal to 0. So that means I want to get rid of this 252 on this side. So I'm going to do minus 252 from both sides of the equation. And that's going to leave me with 0 being equal to x squared minus 9x minus 252. Okay. Now here's where things get really tricky because we've got kind of a monster number there. So we have, let's see, we need it to multiply to make negative 252, and we need to add it to make negative 9. So in the filled in notes I go through, I start at 2, 3, 4, 5. Honestly, you guys, if you start at 2 and you realize that your values are really far apart, like when I did 2 would have to multiply by 126 to make 252. And so there's no way that these are even going to come close to adding to 9. So if you want, you can even jump to like, if I did this one and I realized that, I would probably jump to like 6 times by, I would do 252 divided by 6, which would give me 42. And still I'm pretty far off, right? 6 and 42 will either be 48 or 36. So I'm still way far off of 9. So I would maybe jump to, let's just jump to the actual one. So negative 252 divided by 12 would give me 21. And the difference between let's see. 21 minus 12 should be 9, right? Yeah. So basically that means that I would have the difference between those two is 9. So that's correct. So now I just need to figure out positives and negatives. So if I have negative 21 and I add 12 to it, that should give me negative 9. Negative 21, yeah, plus 12 gives me negative 9. So now I have my values here. And so then I would just jump in and say, okay, my factored version is going to be x minus 21 and x plus 12 is equal to a 0. Right, so setting it equal for what I had here. And so then it's asking me to find the dimensions. Remember, we said that basically means we want to solve for what is x. So if we want this whole thing to be equal to 0, we need to solve for the values of x that would make that true. In this one, remember, it's just going to be the opposite. So it could be x equals positive 21, or it could be x equals, the opposite of that would be negative 12. So now we just need to think in the context of this real life situation, which one of these could be true? Well, we can't have a negative length, right? You can't have negative length for a rectangle. So 21 is going to be the only reasonable option here. So now we would say, okay, the length is 21 and the width is going to be 21 minus 9, which will give us 12. Which I literally just calculated that. I should have had that in my head. Okay, so 12 meters for the width. So now if you were, if you're writing on a test, make sure you write out nicely, like the length would be 21 meters and the width would be 12 meters. Okay. All right, last question here. We're looking at another profit type of a question. So like I mentioned in the previous lesson, this is an extremely common type of question that you'll see. And so it's really important that you're able to work with these kind of problems. So we'll go over another example of that with this one here. Okay, so in this question, we have someone selling posters, the profit function for her business. Last time we used the word revenue, but those words are interchangeable, profit and revenue. So the profit function, profit is just how much money she's going to make, is her profit is a function of how many posters she sells. So N is the number of posters she sells, and P is her profit. And it can be found using this equation. So the other thing to be aware of here, though, is it says that N is the number of posters sold per month in the hundreds. So just remember, any value you have for N, if you want to say the actual number of posters, you need to multiply it by 100. And P, her profit, is in thousands of dollars. So same thing, any value you have for P, you have to multiply it by 1,000 to represent her actual profit. So the first question says, how many posters must Ava sell per month to break even? So when we look at this, P is going to be on the y-axis. Kind of try and do like a little bit of a sketch here. So P is going to be on the y-axis. And so that means, what does break even mean? It means where you just make enough money that you're not in debt. So basically that means her profit would be $0. Okay, so if that's what that means, the number of posters, N, is the X value, right? It's on the X-axis. And so how many posters does she have to sell to break even would be when her profit is at 0. So any point at 0 is going to be an X-intercept. So let's say we have these 2 points maybe. Those 2 points are going to be where her profit is 0. And those are also our roots to the equation, right? So we know how to figure those out because it's just factoring and solving for your N value. So the other hint to that is that it's asking you how many posters. So you want to solve for N, which is the number of posters. So basically what we want to do is factor this whole thing. Now, what you can look at when you have a question like this that has a weird, like a fraction or a decimal out front of your N squared variable or your X squared variable, is you can see if that will divide out evenly out of any of the other terms in your in your equation. So this is negative 0.25. So if we go negative 0.25, oh shoot, why did I do it that way? Let's see if we can, we want to see if we can divide it out. So let's see, 6 divided by negative 0.25 gives us negative 24. That's a nice even number. What about negative 27 divided by negative 0.25? Another nice even number. So basically what that means is we can divide out this negative 0.25 to get nice whole numbers that we can easily factor. Okay, so in a question like this, you might be wondering, why am I not just entering this whole thing in my calculator and solving the way we did in the previous lesson? Yes, you can sometimes do that, but keep in mind on a test you might be told you have to solve it algebraically, and in that case you would need to be able to solve a question like this without your calculator. So our first step is dividing out that negative 0.25 n squared plus 6n minus 27, and we're dividing it all out by negative 0.25. So, of course, that's just going to cancel out for this one, so we're left with n squared. We just figured out that 6 divided by negative 0.25 gives us negative 24, and the variable will stay with it, n. And then negative 27 divided by that gave us negative divided by negative is positive, and the number value is 108. Okay, so again, we would want to go through our factor tree, things that multiply to 108 and add to negative 24. So again, I'm not going to make you guys sit there while I try to work through them all. In the end, the value that you get should be negative 6 times by negative 18, and you can look at the filled in notes if you want, to see how I worked through the different factors. Negative 6 plus negative 18 is going to be negative 24. So those are our two values. So I can factor this into, whoops, wasn't x for this one, it's n minus 6 and n minus 18. Okay, so now that I've done that, I know that those two things are equal to 0, right? So if I want those to be equal to 0, that would mean n would have to be equal to 6, or n would have to be equal to 18. Now keep in mind we mentioned that the number of posters sold would be in the hundreds. So if we're wondering how many posters she needs to sell per month to break even, it would be, if n is 6, it's actually times by 100. And same thing down here. So n would have to be equal to 6 times 100, which would be 600 posters, or 1800 posters. And so basically what it might be hard to understand, why could she break even at 600 but then again at 1800? The reason is that this formula is taking into account the costs that she has and the pricing of the posters. So if she sold 1800, she might have to price them so low that even though she sold a lot, she would she wouldn't get a good revenue, right? So it's kind of like the last one where we looked at, where it was if you have a graph that's shaped like this, your maximum profit is going to be at the top here. And then if so you're maybe starting at a low price at this end and increasing the price, so you're selling more, but that's going to max out at a point. And then after that, if you keep, sorry, did I say increasing the price? I meant decreasing the price. So if you keep dropping the price, you'll be able to sell more and more and more. But then if you keep dropping the price, eventually your profit is going to start going down again, even if you're selling more. So your numbers are going up, but your price is dropping. And so that means that your revenue is also dropping. Okay, so for this one, again, if this was a written question, you would nicely write out she can sell 600 or 1800 posters to break even. The next part of this question is, if Ava wants to earn a profit of $5,000, how many posters must she sell? So basically we're looking for, if y is equal to 5,000, what would her n value be? So we want to set our equation equal to a profit of 5,000, but keep in mind that the profit is in thousands. So instead of saying 5,000 is equal to this whole equation, we need to divide it by 1,000, which gives us 5 for her profit, is equal to negative 0.25 n squared plus 6n minus 27. Okay, so now when we do that, we want to set this whole thing equal to 0 again to solve it. So we're going to minus 5, which is going to give us 0 is equal to negative 0.25 n squared plus 6n minus 27 minus 5 is minus 32. Now again, it's better if we can see if we can get rid of that negative 0.25. We already know that the 6 will work, but let's try negative 32. Negative 32 divided by negative 0.25 gives us 128. So nice even number, so I think we can divide that out. 0.25. So these are just going to cancel, so we're going to be left with n squared plus 6n divided by that gave us, what, negative 24n. So we don't need a plus sign there. It's going to be minus 24n. And then negative 32 divided by negative 0.25 gives us positive 128. Okay, so there's our equation. Now if we can factor it down, so again we would look for two numbers that multiply to make 128 and add to make negative 24. And again, I won't make you sit through while I try all the different numbers, but what I ended up with was negative 8 times by negative 16. So negative times by a negative to get a positive. Negative 8 plus negative 16 is negative 24. So that means my brackets are going to be n minus 8 times by n minus 16. And that's going to be equal to 0. So my values for n would be n equals positive 8 or n equals positive 16. And again, because her numbers are in the hundreds, we would multiply those both by 100, and we would say she can sell 800 or 1,600 posters to earn a profit of $5,000. Okay. So last one is to state the domain and range. So with this one, we are always considering like the reality of the situation, right? So if I'll kind of sketch that graph out again. So if we have our profit, oh shoot, that's not profit. N is on our x-axis. So if we have our numbers of posters sold and our profit, we want to think about what is realistic. Could she have a negative number of posters that she sells? I mean, let's assume that we're not considering any possible theft that might happen. So we'll say no, right? So her values have to be above 0. And basically that's the only, well, let's see, n. Actually, you could say that she wouldn't be able to sell more posters than what would give her 0. Although, I mean, technically she could, which would bring her profits negative. So actually, I wouldn't even put that restriction on there. I would just say for n just has to be greater than or equal to 0. So she can't sell a negative number of posters, but she could sell too many posters in a bad price range that would lead to her having negative profits, right? That would lead to her having a loss. Okay, so now for the range, our range is P. And again, we want to think about what would happen here. So the profit obviously can't be above the maximum here. Basically, with all of our quadratics, remember that our y value or our y component, regardless of what variable represents it, is always going to be, it's always going to have either a minimum or a maximum. Okay, so y is never just going to be equal to all real numbers for these quadratics because the maximum and the minimum of the graph always limit that. So the y value is going to have to be less than her maximum. The other restriction that will happen for like a parabola like this in this real life situation is that, like we just said, she can't sell less than 0 posters. So we would need to say whatever value of n is at 0, we can't have a p that goes lower than that. So what I would personally do here is I would go into my graphing calculator and I would enter in my original equation here. And even though, like, so on a test, on a written, say a written question on a test, for example, if it asks you to solve this by factoring, you have to show all these steps. So you have to have this skill, but that doesn't mean that you couldn't always verify your answers using your graphing calculator. So even though you know how to do all this work, if you can still put it into your graphing calculator and you know how to check whether your solutions are correct, that can be like a nice little backup for you, right? So that you don't make any kind of silly mistakes when you're doing these questions. Same thing for this one, like personally to solve for the domain and range, I'm not going to go in and do a whole bunch more work with algebraically to figure out these values. So what I'm going to say is I know that my y value has to be, let's see, it has to be less than the maximum. So I went in here already and I put the graph in and I checked for, like, you know, I do second function trace, go to my maximum, and I go to the left and I go to the right. And I get that my maximum is 12, where x is 12, but y is 9. So that means y has, or p in this case, which is y on the graph, but p has to be less than or equal to 9. What does p have to be greater than? So basically if n is 0, that's like the lowest we can go, right? So for her profit, if we have 0, you could just put in, let's see, second function trace. It's basically when our x, so n is our x value, is equal to 0. And so if we go into that, we see that when x is 0, our y is negative 27. So that means our profit has to be greater than or equal to negative 27. So that kind of sucks because that means if she sold 0 posters, she would have a profit of negative $2,700, right? She would lose $2,700. Unfortunately, that's the reality of business, is if you don't sell things, you'll be at a loss. So now we have our proper real life range that represents this situation. Her profit has to be greater than, basically if she sells 0, greater than or equal to if she sells 0 posters, but it also has to be less than or equal to her maximum possible profit. Okay. All right, so that was a long one, you guys. Thanks again for sticking it out. And so go ahead and try the assignment here out of the textbook. And next time we will look at solving quadratic equations by graphing. So get ready to go back to the nice, easy way of using our graphing calculators to solve these problems. So I will see you in that lesson.